Welcome to the Talking with the School of Transportation podcast, presented by Centennial College. With your hosts, Ian Campbell and Harna Gill. Let's get into it now.
Welcome back to the Talking with the SOT podcast. I'm here, as always, with Harna Gill.
Hey, Ian. How you doing?
Doing well. We have a pretty special guest today, a returning guest.
Mr.
Chudy's back.
Chudy's back. Guess who's back? Back again.
I have something that made me laugh really hard that Chudy did recently. So we were changing LMSs to this new Luminate from Centennial, and I was trying to add all the faculty into the course shell. And I look, and it's Daniel Chudy. I type his name in, I add him, and I'm like, wait a minute, that's Jesse Kennelly. Wait a minute. That's Daniel Chudy's name. And I was like, why is the picture Jesse? It's really messed me up.
We like to keep our students on their toes.
Yeah,
right?
no kidding. It's like, wait, you're not Chudy.
That's good. That's good.
It was fun.
That photo's staying too.
Yeah,
I'm not switching it.
That's not a bad idea. I think my picture is going to be Jesse as well. Just everyone's picture is Jesse. That's the default.
Yeah. Well, we're back for another body shop
segment.
Yeah, I guess, and more of a collaboration, I think, because what we'd like to talk about is the relationship between the body shop and traditional mechanic shops, I guess.
Yeah, and I think it's really unique, interesting because we get our aspect, and I can tell you, I tell my students sometimes that, you know, you detect frame damage and your next step is to kick it to the body shop. It's like once we get into a bent frame, we don't have the license to pull it. We're not, you know,
or fix it,
or fix it. Aside from like, you got one option. If it's a full frame, you can replace. That's about it. But, you know, what's the other side of that? And also very important is to be actually able to detect that frame damage.
Sure.
To know what's going on. And it's not just frames. There's so much other stuff there. We were talking about a little bit earlier, LiDAR, that's that adaptive cruise control and all this other stuff that our perspective and how we see it from a AST side is technicians who are like, you know, we really drill it, diagnose, right? I know I do with my level 3 students, level 1 students.
Yeah. And we were talking earlier with Chudy about, you guys don't really diagnose. It's kind of, is it broken or, you know, well, I guess there is diagnose in some senses.
It's a different diagnosis.
Yeah. So what does that look like as a body shop guy?
Well, you know, like you got to think about like the overlap of the two trades, right? Because we do get into a lot of the mechanical components of the car, and our license covers like suspension, exhausts, heating and cooling systems, air conditioning, glass. Because you guys can do glass, right? And there's glass in your curriculum to a certain extent.
I have a story about glass. I cut it out with an X-Acto knife, and I'll never do a windshield again because I hated my life. But
that's not the easy way to do it. That's for sure. But we teach glass here at the school. We have a glass portion of I think non-structural class or whatever. And you guys do glass. We do exhaust systems. You guys do exhaust systems. Sure. We do suspension and alignment. You guys do suspension. There's a lot of overlap, right? And there's a few exceptions. Like we don't go, like with the 310B structural license, we remove drivetrains, engines and transmissions in order to change frame rails and stuff like that, right? To have access, but we don't go inside the motor at all, like zero, no head gaskets, not even valve cover gaskets, like nothing, right? And same with the transmission, we pull it out, we don't service it at all. But if you go to something simple like an exhaust system, like why would you guys be diagnosing or changing an exhaust system in a mechanical shop?
Well, I guess when we get into it, we look at stuff like, how could that exhaust leak throw the O2 value off and throw this certain code, right? Mm-hmm. Like we really get deep into those types of potential failures with like drivability concerns and that kind of stuff. And one thing we probably gloss over is that if the exhaust is bent, is that potentially causing that leak, right? Something like that. But it's not, we're not thinking right away, okay, the car was hit. Mm-hmm. We're thinking of from like a diagnostic side of things.
And for us, the car is hit.
Yeah,
exactly. So it's been rear-ended or it has underbody damage, right? Yeah. And we're changing exhausts not for rust, not for leaks, because they're damaged. And it's almost always an OE system.
Yeah.
And a lot of times now there's not even a flange to remove it, right? Like you're following the procedure from the car manufacturer to where to cut it and what sort of joining method it gets, right?
Yeah.
And sometimes like you actually have to diagnose the exhaust system, because when the car is done and you're road testing it and it has a rattle, you know,
right.
And where it's, you know, just not quite touching a heat shield somewhere or something like that, right?
For sure.
And because the work we do is like mainly through insurance companies, like there's not a bend it back kind of thing going on, because it's not a service, it's a replacement, right?
Oh, true.
Yeah. And exhaust systems are big bucks, right? Like it's a big thing to miss on an exhaust. Like if you had a rear end hit on a car, and you know, it's like it's 60% the value of the car to fix it, and you miss the exhaust system, like it's actually a write-off, right?
What you're saying there.
Yeah.
A lot of the exhausts, like they're not individual pieces. Like you just change the resonator, change the muffler. It's
they're
tailpipe all the way up to like halfway through the car,
and they're embedded into the bumper half the time.
Even the tailpipes, like the exhaust tips aren't even like removable anymore.
Well, they're not attached anymore. They're,
they're part of the bumper. That's true.
It's kind of neat. And another part of the vehicle we were talking about earlier was ball joints and kind of structural versus, you know, is it worn out, that kind of thing, and where is the control arm sitting or whatnot, measuring. I know. So this whole conversation came up because we teach. Harnick and I were supposed to teach applied mechanical this semester coming up, which is actually a body shop course that normally body shop teachers would teach that, right? And you were saying, well, we teach it way differently than you would, because we're teaching it at what we expect out of a ball joint, which is, you know, a dial indicator on that. Let's measure the wear and all that kind of stuff. Versus where you would teach it as, where is it sitting in relationship to the car? Yeah,
because our ball joint that we're diagnosing has been through an event, right? Like it's not wear and tear.
It's not a lifetime. It's a one event.
Yeah. And usually when we're getting into vehicles that are damaged and we're you know, changing, you know, subframes and control arms and doing structural damage to them, they're fairly new vehicles, right?
Yeah.
So wear isn't really something that we're looking for first, right? So, and like back to our license and what it covers too, like we do all that suspension damage and stuff, right? But our license does not cover brakes at all.
Oh.
I can't do brakes, right? And like, how do brakes get damaged in an accident? Like the wheel would be missing.
Yeah.
So in our industry, we have to do a lot of diagnosis for stuff. Like say as simple as the exhaust system, or as complicated as a bent control arm, subframe, steering rack, and things like that. And we do it like through measuring, right? It's all through measuring, and our investigative diagnosis is trying to figure out what got damaged, right? And it's not always direct damage, like caused from whatever the car hit. It can be from the curb that it went over afterwards.
For sure.
The towing and recovery is a lot different for a damaged car that's been in an accident. And we run into a lot of underbody damage and suspension damage caused by recovery.
No way.
Right? Well, you guys see it a little bit. For us, it's extremely common,
up
right?
For some reason.
Yeah. So you really have to investigate and look at everything. But there's also like secondary damage. Like sometimes, like you know, weight and mass does strange things
absolutely
to the car, and it can be hit in the front and have suspension damage in the rear, right? Same with things like there's weird stuff that you run into over the years, right? Like you can have like the car like run out of gas, and you're like, what's going on? And the sending unit is bent. And it's because that car, like
kinetic energy.
It received like, it could be like, you know, 50 G's of force, right? Through the actual vehicle body, and like weird stuff can happen to these mechanical components that they weren't engineered to do.
And that plastic tank just distorts like crazy or something. That's interesting.
Yeah, there's weird stuff that happens, right? When you look at the G-forces that are like an occupant in the car sees in an accident, they're quite low, but the components that are hanging off of the frame rails of the vehicle, the numbers are like huge, right? Like the forces that go through the car. So a lot of funny things happen, right? A lot, like one of the toughest ones to diagnose too is like full frame vehicles. Like
Really?
Yeah. Like
The force
Jeeps
will transfer easily through the full frame.
No, because there's two forces going on. There's one through the body, and then there's one through the frame, right? And they're isolated from each other on body mounts, and you get weird things that are bent and funny vibrations and noises afterwards, and things that in misalignment.
Well, they're not
right?
isolated.
They're kind of, because they literally the
There's
components are called isolators.
But they're still attached. Whatever one's doing, the other's going to follow.
But the rubber will distort the forces in between,
and they'll actually damage each other, right?
Yeah,
because those like cab mounts are not, they're not really designed for these huge G forces. Like they can't fail, right? Like the cab can't come off, right? But the frame and the body can actually contact in ways that like is not through normal use, right? So there's strange stuff that happens.
As like, it's just such an interesting to think about from a diagnostic perspective. And I also like when I think back to how we have a body shop in house, how quite frankly, a lot of times it's really annoying to deal with the auto body cars because of that reason. It's not the normal failures where you go through your normal diagnostic process. You have to think about it in a totally different way.
Yeah, I think that, and we kind of, as auto mechanics, kind of get taught that you look for the paint overspray, you look for, signs of what's weird on this vehicle. Has it been in a collision? Because that changes your whole dynamic of diagnosing that vehicle, because you never know what's going to happen with some of those. So
but if you're trying to do a wheel alignment on a car that's been in a collision and you're having a problem with a caster or something where you can't get into the spec, like it's really tough to figure out where is the damage, what is bent, what is out of whack, right? And it can be like literally like the hub or the like almost any component
of course
on that suspension system, and anything that suspension system is bolted to as well, right?
Exactly. And not visible.
Yeah.
Because it's not a visible thing that you can see. That's why you need those measuring tools or an alignment machine to see some different angles.
And most vehicles now, they're plus or minus 1 millimeter. And like if a subframe is out by 10, like you have a huge pull.
Yeah.
Oh yeah.
And like, how do you see 10 millimeters of like all these big, huge components with these big bolts and stuff, right? Like it's pretty tricky. And
so
then,
why don't we talk about like what measurement you would take to detect that 10
and how,
millimeter?
and what
like
tools,
how, what are you doing?
what, as a body guy, what do you, what tools are you using and how are you going at that diagnostic?
Well, yeah, I mean, believe it or not, like the most accurate measuring tool that we have is a tape measure.
Really?
Yeah.
Okay.
Yeah. Like, and we have tram bars, we have computer.
So a traditional roll-up tape measure.
Yeah.
That's one of your top tools?
Yeah.
Cool.
And like there is specific auto body ones. They'll hook on holes or they have a magnetic end on it or whatever. But it's just a regular tape measure. It's metric.
What is it? I was going to ask, what units is it in? Is it
it's metric.
Okay.
And
even in the States, is it metric or is it?
Well, the automotive industry is fully metric.
Is
right?
it? Okay.
So when we're looking at a frame dimension sheet, it's all in millimeters, right? And it's to 1 millimeter.
You say the whole automotive industry, but I use Imperial when I'm measuring, like precision measuring. I use thousandths of an inch over metric any day.
Yeah, and a lot of manufacturers still do for machined components. But
but I think for body specs, I pretty consistently do see it in millimeters.
Okay. I also worked at a machine shop that was old school. So like I learned that way and I lean that way. So I'm just curious when.
And what were you using, like 10,000ths of an inch?
Yeah. Thousandths of an inch, 10,000 of an inch.
Well, the auto industry is a little messy, right?
No.
But there's still like sensors and stuff that are like imperial thread, imperial socket, isn't it?
Of course.
I'm pretty,
There's no consistency.
No.
It's a madhouse.
It's surprising that still like they could be building 2025s now and there's still a mixture of metric and imperial.
On the same car, sometimes for the same component.
Yeah. But even like a Jeep Wrangler, like all the body dimensions are in plus or minus a millimeter, right?
Okay.
Well, and I should say like there's most full frame vehicles and the Jeep is I think plus or minus 3 or it could be even 5 for those vehicles.
Really?
Yeah, there's a little more leeway. Things don't have to fit so precision, right? And it's also per section, right? We measure the car in 3 sections: the front section, rear section, and the center section, right? And we're almost always constantly measuring to the center section of the vehicle. It's the strongest part of the vehicle, and that's where we're even measuring ball joints and taking reference measurements for the bolts on the subframe and stuff like that is to the center section. Because it's going to be the most accurate, right?
Now, how do you find the center section? Is it printed? Is there a hole? Is there like a indent or something on the car, or is it a map that you find on your service information? Where do you pull this data from?
Well, so we pull frame dimensions, and they're 3-dimensional measurements for length, width, and height, right?
Okay.
And there's always a ball joint measurement on it. Sometimes there's not the best measurements for like upper radiator supports or subframes, but usually you can figure it out, and there is stuff that's there, right?
I'm just going to interrupt you for a sec. So one thing that we find when we're using ProDemand or our service information is we don't get a lot of those body specs.
Yeah.
They're not there, but you guys have access to a different set of specifications or service manual that provides those specs. Is that right?
Well, it's usually embedded in our estimating software.
Okay.
And that's what we do all of our work off.
Is
of.
is
What's
that
the
a
name
version
of
of
that?
ProDemand? What do you use?
So the one that we have at the school here is Autodex. I think
Okay.
I think it's changed names now. I haven't taught estimating in a few years. I think it has a different name now. But there's Mitchell estimating.
Okay.
There's one that's called I think it's called CC1 now or
And it's
something.
Is
all
it fair to
built
say
into
that
that,
once upon a time that was all in a book?
Yeah. For
Yeah,
sure.
right?
Yeah. It was.
Could you still get said books, or is that's totally
I
gone?
don't think so.
Thanks
no.
to Mr. Mantis, we have a whole pile of 1980s books if you want them. But yes,
We have some estimating manuals that we hung on just for nostalgia and showing
Sure.
people it on paper instead of a screen.
Yeah.
And we have a couple of old frame dimension books as well.
I have a question for you. Do you prefer the books or the online option?
Oh, geez, I don't know.
I would assume that the information is grander in the auto body because of how much. But a wiring diagram in a book is my favorite thing.
Your favorite thing?
One of my favorite things.
Okay. I think I'm with you, right? Like I hit
You know what,
print,
though? I
right?
also have to-
print it out and look at
The
it.
caveat to that is the wiring diagrams when they were in books were potentially simplistic,
Yeah,
more
that's
simplistic.
true. Like a horn circuit on an old car.
Sure,
was just
you
like,
could draw that on a piece of paper, right?
That's easy.
Yeah.
Now it's like wires everywhere, and
Yeah.
that
like
meme of what's his face with numbers
Charlie.
all over his face.
Yeah, and now you print it out too, and you've got it on like 27 pieces of paper that you've scotch taped all together to look at the
Exactly.
the whole circuit.
Yeah. Interesting.
But the frame dimensions are like actually fairly simple.
Okay.
We have underbody dimensions and upper body dimensions. And there's not a whole lot to them. And a collision technician has to like sort of fill in the blanks as well. There's a lot of reference points that the bodyman will make themselves
Okay.
and compare left to right.
Gotcha.
You know what I mean?
Yeah.
And
Like common points left to right. And
Like
and
one thing we
match
would
them?
do in the shop a lot is, particularly when we would get those cars that came from the body shop and they need alignment, you drove it and it's off, you put it on the rack and it's off, and you want to know if something's bent. One of the measurements we would take from the ball joint to a fixed point on the subframe, usually one of the mounting bolts, and then compare side to side.
Yeah,
give an indicator if the knuckle has shifted.
well, that's actually not the way to do it.
Yeah, that's what I'm curious to hear. Like, how does an auto body guy do that?
Because if you loosen that bolt, how much can you shift the subframe?
Quite a bit.
Yeah.
Quite a
So
bit,
it's
yeah.
not a good reference
So
point,
we
right?
want to know, because we're trying to determine, because specifically I'm thinking of like the 300s. You'll remember those, Ian, to do the alignment for your caster. When it was out, you'd shift the bolts, or you loosen the bolts for the subframe and move it. But if a car got whacked and the subframe moved rearward, then that would have the same effect, right? So trying to determine if it moved. Of course, you look for witness marks and all sorts of other stuff. But to determine if something is bent, where are you measuring from?
So the way the car is built, right, is on fixtures. So they actually, like, the robot is like grabbing, like, the first part of the car is probably like a floor pan and a couple of frame rails, right? And they're sticking it on these fixtures that holds it on locating pins and these holes that are built into the car, right? And the fixture is exactly the same, like right to the fraction of a millimeter for every vehicle that's going down the assembly line. And then it's being assembled by robots and spot welded together. And all of those spot welds are within the millimeter as well, because they're all robotically controlled. So the cars, when they come off the line, are extremely consistent. And we go to those locating holes, the fixtures points on the car and the chassis, and the best ones are the first ones, right? So if you think the very first robot on the assembly line that's grabbing the very first parts of the car, right? They're going to be basically the torque boxes, and it's going to build the center section and then build the car off of that, right? So we're always like, we were looking at a ball joint setback. We would measure it to the torque box, and we'll actually like triangulate it. Nice. So we'll go to the rear torque box, the front torque box, and then usually one on the opposite side, and then check those numbers to the frame specs, right? And you can tell actually in space if it's in, if it's out, if it's back, if it's forward, right? Does that make sense?
Yeah.
Totally.
And then, but I think the difficulty we have is we don't have those specs.
Could you
we don't have access.
Mirror it on the other side to see if they match, or is that not a good practice?
Also not a good practice, because some vehicles are set up for road crown, right?
Gotcha. Yep.
And they're not exactly the same left and right.
Caster.
Yeah. And I mean, like some vehicles too, like you have to account a little bit for bushing wear as well.
Yep.
So like we were measuring it to the millimeter, but these things, like if you have the spindle off and you grab a control arm, you can wiggle it around quite a bit, right?
Yeah, absolutely.
And there's also measurements you have to be wary of too, is if the ball joint is loaded or unloaded. So there's a bit to it, but it's fairly regular in the body shop. And basically all this measuring, all this diagnosis we're doing is so when we
lean loaded for those ball joints, wouldn't you?
It depends. So the frame spec will actually say on it
if it's loaded,
or unloaded, right? And for us, unloaded is the best, really, because when we're measuring, it's going to be on a frame rack, and the frame rack is holding it by the frame, not by the tire. So the tires are usually dangling, right? And then the other one, if we're doing a pre-diagnosis to figure out if it even has structural damage to go on the frame rack or not, like it'll be up on a hoist, all the wheels are hanging, right? So and for most of these measurements, we don't even have to pull a wheel on the car, right? Like it can stay together.
Yeah. I'd say the other thing too, and I don't know if your experience is, like when we look at a modern car underneath, it's carpet, like front to back. You guys know what I'm talking about?
Yeah.
All that shields. Silencing.
Yeah.
So then are you able to even work around that, or are you removing?
Well, we're removing it all anyways for diagnosis, right? Because we have to look for damage. Yeah. So there's a lot of investigating that has to go on, right? We have to write like a fairly accurate estimate right off the bat before we even start doing any body work.
Of course.
Because you can't say like, oh, it's going to cost $10,000 to fix your smashed car, and they're like, oh, it's going to be 25
plus this plus that. Yeah,
like, and that happens all the time. So we'll put it in a supplement to the insurance company for this unforeseen stuff. But you want to keep it as accurate as possible, right? Like we don't want to be fixing cars that should be written off. It's not a good way to operate a body shop, right? Like it kind of doesn't work for anybody if you're getting too far into work, right? So if you're changing, like, say, a half of a frame rail, and then you're into it and you find like there's a wrinkle in the floor pan or something's distorted somewhere further down the line, like it's very difficult to fix it after the fact when you've already got, thousands of parts ordered and 40 or 50 hours into the. Isn't another thing that's different with the body shop too? Like our hours are crazy, right? Our labor is ridiculous.
Yeah.
So like a lot of people say, well, how much is it to like change my damaged rocker panel, And it's like 11 hours to change a rocker panel, and it's not painted yet.
Yeah.
Right.
And then it, it's another 4, 5, or 6 hours before it's done. It's like a lot of money, right? In labor, and not really a whole lot in parts, right?
Yeah.
It's kind of the opposite of you guys. You're changing expensive components fairly quickly, right? And
sometimes, yes.
Well, so
comparatively, definitely.
Like a modern car now, like you get hit in the quarter panel, which is like the worst spot to get hit because it's like it's a part of the car that's welded on, right? Like a quarter panel could be 50 hours to change it.
Wow.
Yeah, it's like pretty serious, right? Like
hours-wise, the only thing we have similar is a frame. 50?
Yeah.
No, for
you know
sure.
what I mean?
Yeah,
like that's the closest.
Well, I just meant cost per, because you could replace
like it could be a wiring repair and the cost
of timing cover has to come off, and that's engine out sometimes. Like there's a lot of that little part that's buried. or transmissions.
$5 seal that requires removal of everything.
So there is a relationship there, but definitely yours is a huge scale compared to our stuff.
Yeah. So usually when the car ends up in the shop, the first thing we have to do is a tear down, right? Because we have to see all the components that are buried under plastic and sheet metal and stuff like that, and see what's going on, right? And we have to look for those damage indicators, measure to all the reference points, and see really what's going on, right? Mm-hmm. You can see a smashed car and the bumper cover is still on it. You go, oh, it doesn't look too bad. You peel all that plastic off and the car is just annihilated, right?
That plastic gives. It moves and it springs back and it doesn't look so bad.
And they're using so many plastic components now to hold the front end of the car together, that the damage can really travel.
Sure.
It's not easy, right? So sometimes you can be like thousands of dollars in just to determine that the car is not repairable, right? And be like, this is a write-off. And there's actually like a fairly big bill that's being paid by the customer or the insurance company just to say this car can't be fixed, right? And these mechanical components that get involved in that get bent in these collisions, they can play like a big factor in it, and they're quite easily missed, right?
Well, we were talking about those a bit earlier. AC, cooling systems, evap system, like a whole bunch of stuff. Electronics as well, right? You have if you short some of the components out based on the wires, like the modules could be in trouble, depending on what's going on. So there's a lot of things that could happen because of an incident like that.
And there's two things that spring to mind. One, that's always my biggest gripe with the auto body stuff is like, I get time. Like you'll get X amount of time, like a lot of time to fix it. I'm doing an alignment for 1.2. Yeah. And if there's some sort of damage, like I don't have very little time to figure this out. Right. And that's where I feel for like our students who are also trying to determine, is this a body issue? Was it in a collision? That's why we also have to ask those questions. Mm-hmm. But the other thing that comes to mind is a common thing, an experience of mine that I've told to students, where I have a customer come in with ACC in-op, the adaptive cruise control. Yeah. And sure enough, like you ask the customer, were you in an accident? No. You look at the bumper and it's full of fish eyes and it's not quite the same color as the rest of the paint. And you're like, okay, well, this was painted. Then you lift the car up and you inspect it. The module was offline, right? So offline module for us is power, ground, bus. Those are the three things to look at. But clearly the car wasn't an accident. So I'm not going to do my regular diagnostic. You have to look for those areas where, did it get caught under a component? Did they route the wiring wrong? What is it? And then, of course, when you show the customer the bumper, they're like, oh, yeah, it was hit. And then what happens? Okay, it's not warranty. You're just paying your 1 hour diagnostic time and get out of here because they don't, back to wherever it went, right?
Possibly,
so that's, usually because they'll go back to the body shop that did the repair, try to get it fixed under their insurance also, right? So that's always kind of been like my relationship with the auto body stuff.
Well, it's getting more and more intertwined as the cars get more complex. Like there's like in the shops, like the way it was like 25 years ago is they just fix the car, it measures okay. Send it sublet to wherever to get a wheel alignment. Usually burn like half the shops around the, you're just having to tow it further and further because nobody wants to do those wheel alignments. And you can't do that. Like back then you would spend the time on the frame rack so you're not like screwing over the mechanic that's trying to align it afterwards. Mm-hmm. But now it's so complex. Like just you're saying about a bumper. Well, like if you actually read the body manuals for some of these cars, there's a bunch of spots on bumper covers where there's sensors behind, especially the blind spot monitors and stuff. Yeah. Like some manufacturers, we can paint it once and that's it.
Because of the thickness.
Because the paint.
Yes.
Right. And some of them you can't at all. Some of them are twice.
Yeah.
Right. And those measurements like to a rear body panel are so important. Like if that like in people, as they trust these electronic systems more and more, like they don't check their blind spot. If the light's not on in the mirror, they turn, right?
Yeah.
And if something's wrong with that bracket or that sensor, or like it could literally be the thickness of paint that's on the bumper cover.
Yeah.
If there's a repair there, like if we put a bumper like plastic repair on it, like every manufacturer, you cannot do any sort of plastic repair in those areas because the sensor's not calibrated to look
so
through
specific.
They're only calibrated to look through 6 millimeters of plastic, not 7.
It's funny because I've actually had that once where a car came in and the Parktronics were in op, not reading any of the rear sensors. So you're thinking, am I getting my power? It's a shared power. And they were all painted. You only realize when you go out and look at another car
and they're all black.
That they weren't supposed to be painted.
Somebody touched them up and wrecked their sensors.
There's a post that I was reading years ago about someone put the wrong T on a Toyota Camry. And it had like the pedestrian avoidance auto braking system. And the sensor it would calibrate. But every once in a while, it couldn't see through the chrome T emblem, and it would just slam on the brakes.
Wow!
Oof.
And the customer was like losing its mind because it was like if the collision shop does a good job, and every single little detail is so important for even these mechanical systems afterwards, that like there's this stigma that if your car's been in an accident, you just got to get rid of it because it'll never be the same again, which isn't true, right?
If
it's fixed, it's fixed, right? But
if it's fixed with integrity.
Well, if it's fixed by the right people,
but it's just not
right. Like that's someone who does the job correct. Just like a mechanic. If I don't rebuild an engine right, well, that engine's not going to be right.
Yeah, and if you're looking at the body shop and you're looking at 2 Toyota emblems and going like, this one's chrome and this one's silver, and this one is like back ordered for 6 weeks. You smack the chrome one on and say, well, like, what the hell's the difference, right? And then the customer's freaking out because their car is randomly slamming on the brakes. And then it's back in the body shop because it's been rear-ended. So sometimes it works out,
But get changed a second time. Oh, those parts are here now.
But there's tiny little details like that, it's like an overlap between the auto body and the mechanical that you can't see unless you stand back and look at the overall picture, right? Yeah. Like you can have. There's another one that I was reading about. A tone ring had some rubberized undercoat on it because the technician that was working on it just didn't cover it. And then it all got built back up and nobody thought. And then it has this intermittent ABS and stability control fault that no one can diagnose. And there's hours and hours into it to find out that, it's just some rubber debris that's splattered on the tone ring, right? Like there's strange things that can happen.
And
it's so detailed
and easy things that could be avoidable if you kind of did that job well,
right.
And we see that all the time on our side too. Yep. Putting the brake pads in the right way works. The steel on steel does not work.
Well, we're not allowed to do brakes, so
why? I was going to ask that. Why though?
But Joe Blow can do his brakes in the driveway.
That's
can he not do his buddy's brakes?
That's like doing electrical. You can do electrical on your own house.
I guess you can't certify it. It wouldn't be certified. That's true.
But why do they? What is it about brakes that they don't allow you to do?
I
figure they just don't consider it's part of the purview of auto body.
I suppose, and sometimes the brakes are damaged, and the body man's going to change them, but then it'll go to the mechanical shop to be looked over, inspected, and make sure everything's cool, right? Like the mechanic basically just have to sign off on it. But
in my mind, that's kind of silly because brakes are pretty simple. Comparatively,
it's just that they're so important, though, right?
Yeah, but so is a control arm. Sure, there's a lot, like a ball joint and a control arm. If that falls off, you're in trouble too.
There's no training portion for it, right? So
for your
I guess they're looking at it going
listen, we got to get some hours.
Yeah,
on the EST side.
But and if you go to something as simple as a wheel, we do wheels, but not brakes, right? And when we're teaching the students, it's how important is the hub center and the hub, right? How important are the wheel studs? Well, it's not about the thing going down the road, right? It's about it colliding with another vehicle or going over a curb and your wheels staying on, right? Like a steering rack, and the suspension components aren't actually designed to drive down the road. They're designed to crash into stuff, to drive over huge obstacles and the person be able to retain control
in your industry, because they have to be comfortable for our industry.
For us, it's like precision. We want that wheel pointed the right way.
But it's a different. It's a different diagnosis. It's a different mentality. It's a different thing that we're looking for, right? Like when we get bent wheels, there's always bent wheels, right? And the way we inspect tires is totally different too, right? Because you have to assume this tire has smashed into something, right? Has been over a curb, right? We inspect them different than if you were doing a safety certificate, right?
So what do you look for?
Well, we're looking for, bulges and shift belts and like really it's a visual thing, but we'll put it on a balancer and we won't even like pay any attention to if it's balancing out to 0. We're looking at how it's moving around in a circle, right?
You don't care if it shakes at 100. You care if it's going to wobble at 15.
Yeah. And I mean, like years ago when I was in the industry too, like the road test is like very comprehensive, right? Like you have to do everything.
Yeah.
And
what does that look like? What would a road test look like?
Well, I mean, I worked at a very small like mom and pop shop, but you had to be thorough, right? It's in a small town, and it's one of those things where you could be the best shop in the world and somebody might recommend you to a friend. But if you screw over one customer, they're writing articles in the local paper and telling everyone they know. They're blasting you on Facebook. So you really had to go over and above all the time, right? And we do a road test, and it was never one person. It was usually me and the boss or me and the mechanic that worked there. And we would literally hit every single button in the car, right? And make sure everything works. Because you'd be like, one car I was driving, we did a huge repair to it, right? And I turn on the blower motor and it goes like, and then it's silent, no wind's blowing. And it was like a part of the plenum had actually cracked, and it was contacting the blower motor like squirrel cage, and it destroyed it, right? Like it just obliterated it. And we had to pull the dash, pull the airbox out, replace it, put a new blower motor in it, and the car was completely done. The customer was supposed to pick it up the next day, right? And this crazy stuff happens because of these huge inertial forces. We have to pull every seatbelt and inspect it and let it retract to make sure it works correctly before we fix the car and afterwards.
That's it. What about pretensioners and airbag stuff? How does that work for your estimate or whatever?
Well, I mean, like we're gonna see a lot in the pre-scan. We have to do visual inspections as well. We're also measuring like steering column length. Because a steering column like just doesn't collapse. It can actually partially collapse, right? Totally. And they break away in a severe accident. But if someone just, especially like a bigger person, if they just brace themselves on the wheel, it'll actually partially break away. Because the way the steering column is affixed to the dash carrier is it's designed to shear off and then collapse into the footwell, basically, right?
Yeah.
And like it's more common than you would think to have even something as simple as a bent steering wheel rim, right? And how do you notice?
Yeah.
Like, so we actually turn the wheel from lock to lock and watch it return on its own and look for the wheel wobbling, right?
Set up a dial indicator.
Yeah. And like I remember fixing a pickup truck, and like we did all the pre-checks after it was done driving it. It was like, ooh, it is a little bit bent, and just like holding on to it and just bending it back a bit. Like the top of the steering wheel, I guess it was one of those guys that has his hand on the top, and the top of the steering wheel was bent like maybe a quarter of an inch, and it's so easy to miss something like that, right? And a steering wheel is like over ungodly expensive, right? And we can't like hit the auto wreckers and buy an airbag or a steering wheel, right? Like it has to be a new part.
Yeah.
In order for us to guarantee that the car will behave and act exactly the same in a subsequent accident. But these systems are getting so complex in cars now. A lot of the body shops, a lot of the technicians, they're actually putting all that onus on the mechanical shops, right? Yeah. Sublet. Yeah. Right. So if the airbag system, nothing works, it's their liability of the technician that diagnosed and did it. So like, I mean, we have to be careful when you're working on a car that's been in a collision. The mechanics have to be very careful too, right? Like it's not how the car drives. It's like it was in an accident, and it seems crazy, but I've seen it. People get in the exact same accident again, right? And the car has to behave, and all of the systems have to function exactly the same as again, right? Like it's a big deal. Like everybody complains, like when they're get in an accident, oh, it's taking so long in the body shop, they're waiting forever, and it's just excuse after excuse. But cars are crazy complicated now, right? And we have to make sure everything is perfect, right? And we have to deal with wind whistles and water leaks and stuff. Like constantly, right? And they're very, very difficult to diagnose.
Oh, we know.
Yeah.
Water leaks are the bane of my existence.
Yeah.
Good old Wrangler.
Yeah.
Yeah. And part of our road test is checking for all that stuff, right?
Yeah.
Like I've been shut in a trunk a couple of times and either been driving down the road.
It wasn't working that day. It wasn't working that day.
Or being sprayed with the hose, to find where the leak is coming.
You owed money to somebody, didn't you?
Yeah. Well, and there was a car, like, I was in the trunk, and I think it was the co-op kid is like blasting with the hose, and I'm in there with the light, and I'm seeing this water drip out of the trunk channel.
Yeah.
And like, I can't, like, where the hell is it coming from? And we actually had to grind the paint off in the seam sealer to find it. It was a porosity in a single spot weld.
Wow.
A tiny little pinhole, and it'll suck the water through, right? And it's not like weeping. It's going drip, 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 right? And overnight, like, it would fill the whole spare tire well up with water, right? Like, it's actually drawing the water in.
For sure.
Yeah, and there's funny stuff that happens. I remember, what was it? Like, showing my age. I think it was a Buick Park Avenue.
Okay.
Which I don't know how long it's been since they made those, but it's been a while. But it actually had a water leak from the rear wheelhouse. And it actually just like wetted the rear seat. And the airbag module is underneath there. Yeah, and it fired off the passenger airbag, right? Busted the windshield, busted the dashboard.
That wouldn't happen anymore.
No, and you're going like, what the hell happened?
My Impala, it was an 05, and when I bought it, I was like, oh, I think this guy cleaned the carpets. He didn't clean the carpets. The cabin air filter seal, someone changed the cabin air filter, the seal would just fall off, and then water would get in. And then the front passenger side would fill with water. And of course, that's also where that airbag module was. I'm lucky it didn't blow anything, but it created a very similar issue.
I had a 91 Sunbird that the back seat would just fill up all the time. I just put a punch in it and made it whole.
So that
little different than how the auto body guys approach it.
I was bang, it'll drain now.
So that Park Avenue, and it was very, very new, had a quarter panel put on at the GM dealership.
Okay,
down the road, and it was a pinhole in the seam sealer between the inner and outer wheelhouse, and it was all like it had the rubberized coating like put into the wheel well, and you could not see it, right? But when it was driving in the rain and the spray would hit that little pinhole, it would suck it in, and you'd have no idea because the back seat, like, no one was sitting in it. It was like a elderly person that owned the car. The thing was mint, right? Like, we wax it every Sunday.
It was mint.
Yeah. Well, we fixed it, right? We actually fixed it. We bought a new airbag for it. We put a used dash, a windshield in it. He was a longtime customer, right? Mm-hmm. And like, it's almost a shame that he's owned this car right from new. The thing has very low miles on it. It's perfect. I don't know what it was, like maybe 14 years old, but like, I don't know. So
now it's been an accident and he's got to get rid of it.
Yeah.
It's never going to be the same. It's never going to be the same.
But that little leak in the wheelhouse had been there doing that for 10 years, right? And he had no idea because you'd have to be in a major rainstorm before it would be wet enough, and then someone would have to sit in the back seat and go, "Oh, my bum's wet," like, it's just the impossible diagnosis, right? And then you're driving along, go do, and the airbag explodes out of nowhere, right? Like, there's crazy stuff that happens. Like, it's very, very detail oriented industry, and as these cars get more and more complex, like that car, I think, was like a 2001 or something like that. Like, it was a while ago, right? But
it would, or older.
Yeah, but the new cars have all the same stuff, right? And then they have like layers and layers of electronics and crazy computer stuff. Like now, like, a body shop gets a headlight and basically like a regular car, and you're holding like a $4,000 part in your hands, and you bolt it in and hook it all up, and it doesn't work. It has to go to the dealership and be programmed, right? So the relationship between the auto body and the mechanic shops are like very, very intertwined now. Like, we can't do really anything without
that's
scanning and.
Yeah, I know our auto bodies our body shops. First thing is scan the car, get a printout, and then submit that off. So I guess when I diagnose something, there's a procedure, or like when any technician does, we follow what we usually call with Dodge is a 6-step diagnostic procedure. Pretty much everyone's got the same logical diagnostic procedure. Do you guys have something similar, or is it more like situational based, depending on how the car was hit or circumstance around the collision?
Well, it's pretty crazy, right? Like I talked to this guy that worked at a body shop years ago. I think it was called Laird Auto Body. And like the guy fixes like at the time was fixing like 90% Crown Vics for the city, right?
Nice. Yeah.
And I was like, isn't this boring? He's like, you'd be amazed the way they find to smash these cars up. He said it's never the same job twice, right? And he's working on the exact same vehicle over and over again. Like imagine all the array of different vehicles that are out there. Full frame unibody, and then we have mixed metal aluminum vehicles. They're putting carbon fiber in pickup trucks now. Like it's crazy, right? And then all the ways that they can be damaged: underbody damage, T-bone rolled over, like hitting the back, hitting the front, like all different directions, all different speeds. And we have like bumper incompatibility and like you used to ditch a car. You'd be like, okay, let's throw it on the wheel line machine and see what's bent, right? Mm-hmm. Now, like you end up in the ditch in the winter, the car could be a write-off.
Yeah.
Right. And before we would do a visual inspection of like a steering rack, right? Because we always have to look at the steering rack when it's been hit. Because if it gets knocked hard enough, like we got to pull the bellows and see if it's leaking and all this stuff. Now we got to scan the thing, right?
Yeah.
And sweep it left to right and make sure it's all working properly, get the zero back again, like check for play absolutely everywhere. Like it's so complex now. It's unbelievable. The pickup trucks, especially, like for me, I find diagnosing those are the most difficult because they're extremely complex and they're very robust, right?
Yeah.
And some of their procedures are like way different. Like the body men who do trucks and the body men who do cars are doing very different jobs on the frame rack, right? Like the trucks are pretty wild. And some manufacturers, you can change parts of the frame. Other ones, is the whole thing. Some of them have a sectioning procedure for the back, for the front, 2 or 3 different spots. And they have to be right on point, right? Because it's like you guys know, when a vehicle it tows, it's a whole different ball game when you're trying to, get it to drive straight and behave properly, right? Like
for sure.
Even things as simple as like aiming the headlights, like if it's a work truck, it's a totally different thing, right? Well, just think this thing
weight in that vehicle changes everything.
Yeah. Well, now crash it.
Yeah.
Right. And we have these like crazy secondary damages and all kinds of loony stuff that happens to vehicles, right? And you get a pickup truck in there and you go like, okay, it's hit in the front, right? Was it towing anything at the time? If it is, like, it is a whole other can of worms,
How
right?
much did that twist on that end?
What was in the bed?
Yeah.
Right? Like, if there's a toolbox or, like, I don't know, anything. Like, I remember I fixed the truck years ago, too. It was a piece of junk. We wrote it off. But the guy just had a transmission in the back, like a turbo 350, right?
Just loose.
Crashed the truck. The tailstock like pierced through the cab by like 8 inches. It was like halfway into the cab of the truck.
It's like Final Destination.
Yeah, and like the thing was in the yard and had been looked at by a couple people and me as well. And I didn't even notice it the first time. I just go, oh, there's a transmission up there, and then you're like, look at it a little closer.
Well, there's
wait
a transmission through there.
yeah. Now when he sells
you
that
go to pull it out, and I'm like, why is it stuck? There's a lot of stuff that goes on. So
that's cool.
Yeah,
it's such a interesting like difference between how close we are. Like we teach side by side, we teach the same students a lot of the times, and yet
we're teaching like the same product.
Yeah,
right?
we literally that applied mechanical course. We're teaching cooling systems, whereas you're teaching like, okay, does it look okay? Is it built properly? Is it installed correctly? And we're saying, is it flowing okay? Like we're that different style of thing.
Well, I mean, even for cooling systems for us, like we're not looking for cooling issues.
Yeah.
We're looking for damage, right? And so much of the cooling system is plastic, and it's right on the front of the car. So we like, and we're mostly just changing components, and then filling it up back, making sure it's the right coolant. But like, so another thing like is the transmission cooler, right? So there's this thing now, which is insane to me, but there's lifetime transmission fluid, right?
Oh, yeah.
And like, where's the transmission cooler?
The cooler, right up front.
In the rad.
Or sometimes,
In the
well,
rad.
sometimes in the rad, and then there's a lot of variants.
Yeah.
Some of them are in the rad, like if you're looking at like a Honda Pilot style,
Yeah.
where you get your milkshake. We've always talked about the milkshake. And then you have these heat exchangers that are on the transmission or
The new ones
further
have that,
downstream.
yeah.
And that's newer, but like 10, 12 years at least.
true.
It's not even, it feels new, but it's been quite some time.
Yeah.
So, and how much is that fluid?
Expensive.
Yeah.
We were
And-
just
and
talking
how
like
do you-
$30 a liter sometimes.
So,
And
at minimum.
Yeah.
Yeah.
And how do you read the level of the?
Yeah.
With a scan tool.
Yeah, with a scan tool, get it up to temp, but it can't be too hot and it can't be too cold.
And
Take
the
this
car is-
impossible bolt out that you can't reach.
And the car is sitting there smashed.
yeah.
And there's
Yeah.
literally been like sublets for like, you know, like say a BMW 3 Series for the transmission fluid, which actually pushed it over and the car should have been written off, right? Just from the fluid. The fluid is like the tipping point, right?
That's so fun because we see that with rebuilding transmissions as well from the warranty side, push you over the 70%.
Yeah.
And it's the same thing. It's just the cost of the fluid is like sometimes enough.
And it's hard to wrap your, we're doing such similar things, but it's a totally different way of thinking, I suppose. Like we're looking for different stuff and we're not worried about like the transmission, like shift condition or anything like that.
I was just going to ask that because do you ever worried about loss of transmission fluid wrecking the transmission itself? Is that a factor for you guys or no?
It can be, but how could you possibly?
You can't know.
Like there is instances where you fix the whole entire car and you're road testing it and the transmission is done.
Yeah.
Right?
Yeah.
What do you do? Like it's a long conversation
you
with the
lose that
insurance company
oil-
or the customer, but
And how does that just very curious now because I could see that. How does that go with insurance when you like?
well, the insurance company's pretty understanding usually because this stuff does happen in our
And they
industry,
see it
right?
every
And
day.
there's no way to road test a vehicle that's smashed.
So
right?
that means
Because
so they're
do it.
reasonable.
You could do it.
Head out the window.
So if you're going like all of the transmission fluid is gone, so the car was left running and it's spilling its guts on the side of the road,
Yeah.
right? Like now we do have to like before we start doing the expensive stuff on the car, like get these components to sort of seal it back up. And a lot of times we'll just put it back together without that cooler, just
Right.
plug it, get the fluid back in it, and make sure it goes into all the gears
Sure.
and it's not throwing crazy
And
codes.
same with engines. Like if you pierce an oil pan and lose all your fluid,
Yeah.
like you could blow an engine
Yeah.
with that stuff. Do
And-
you factor that in or do you think about that or
Well,
is that in that visual check at the beginning? You found something leaking and we need to look into this more? Or?
So back to like, there's so many different ways that the cars can get smashed. There's so many different. So the shops really like they kind of develop their own procedure.
Okay.
Like mostly at the shop level. There's not really a part of the manual that says like there is like check all of these things, right?
And that's experience.
Yeah,
I would say that you have to get in there and see the things to gain that experience to learn your knowledge and
this is another reason why trucks are kind of more challenging because they're very expensive and they have huge resale value. Like they retain their value really well.
Yeah.
And like that's about the only vehicle that you could actually like roll over and it could be fixed.
oh wow.
Right. And like what do you do with a rolled over engine? When it rolled, it was running.
Right.
Possibly.
Like all kinds of crazy stuff, right? Like and we have to really like investigate and go nuts. And like
I mean if it's Fast and the Furious, it'll just
yeah,
keep
like
going.
in sometimes
Roll right back. And then
we're checking it all out. You tow it to you guys check it all out, tow it back to us, and then sometimes it has to happen a couple times before. Yeah,
that's sitting out back for a while, running with blue smoke flying everywhere.
yeah, and then like, well, now does it need catalytic converters? And
Sure.
yeah.
like it's just like everything is kind of like
That's
a
why
can
you
of
sell it after it's been in an accident.
It'll never be the same, folks. It'll never be the same.
Yeah.
I love it. This has been a real fun conversation. I'm excited to keep going with the body shop. But we need to get Daryl Roberts on. We've been talking about that a lot. And Chudy's the second time. I expect this to be a frequent flyer because there's just so much knowledge and information that we can talk about between the two. I think both sides. Hopefully both of our students can learn a lot about how to diagnose and how to tackle new things, and try that. So yeah. Well, I think that's a good time to like ask Chudy a couple new questions.
Oh, what's the new questions now?
So I guess our first question will be, if you could have any meal anywhere, any place, right? Yeah. Anywhere in the world. And you can focus on the meal. You don't have to focus too much on the place unless there's an ideal location you have. What would it be? What's your ideal meal?
I'll explain this to you. We had Alex on from the motorcycle department.
And we liked his answer so much. His
answer was so cool that I was like, this should be a question. And what he said, he went on a motorcycle trip years ago in the Alps. And there was this little town. And he had like, what was it? Soup and baguette or something like that.
He's like, I need a meal. And he talks to someone. He's like, well, go get the bread from over there. Yeah, and you go over there and you get the wine. And then you go to the cheese guy.
And then you sit here and you eat it and looking at the mountains. And I was like, that's the coolest answer.
Now, if you want to say in your basement, in your underwear with some mac and cheese,
some pizza,
so be
by
it.
all means.
So be it.
But what do you think? Do you have a meal? And it could be as grandiose as you want. Money's not a factor. What do you think?
Yeah, well, I had this meal. So I went to Japan with my wife, and we went to like see Mount Fuji or something. We ate like 1,000-year-old egg, and we had this option where you could take like the bullet train back, or you could ride this like trolley with the locals. So we hopped on this trolley. It's like wooden, and it's following this little river, so it's twisting everywhere, and it's dropping everyone off in their little towns and stuff. And it took us we ate the 1,000-year-old egg, and then it took us 1,000 years to get back to like the hotel. And it was in this little town or like Airbnb, and like all the restaurants were closed. We're walking around trying to find somewhere to eat. Japan's weird. You can only everything's cash. Oh. Right. And the only place that like could take us was an Italian restaurant. I'm like, I didn't come to Japan to eat Italian, right? So we had no choice. We went in there. And they had like a whole ham like leg, like prosciutto.
Okay.
And they're like shaving it with like a samurai sword. And they had like a wood fired pizza oven, and so they had like wagyu steak on the menu, right? And I was like, well, whatever. So we're like counting all of our money to make sure we have enough to pay for it. And we ordered this like wagyu, and it was like thin little slices. Like it probably was like 2 ounces of wagyu, right? But they shoveled all these coals out of the pizza oven and put it in and they lowered this like grate from the ceiling on chains. And then they like seared this little steak for us. And like, it was ridiculous. It was so
That's
good.
So cool.
Like, and it's just like this one weird situation where you'd be in this one weird meal that you never intended in having, and it was just so amazing. It was so perfect. It was such a cool night. This little village, we're walking around trying to find this restaurant, right? And it was famous for its like steam bath. So it was like it had a natural like hot water spring. Yeah. And like it's like it was dark and all the street lights are on, and it's just everything's all misty, and it was just so cool. Very right neat. And I would go back there in a second. It was like one of the single best meals I ever had in my life, right? And it was just totally like should have never even been there in the first place. You know?
All right, to double up on that question now, and you already said you were there with your wife, so your wife and kids you can't take.
Oh, you can't?
No, we're not letting you do that because that's an easy cop-out answer. If you could take 2 people, anyone to have a conversation with at that meal again, who would you take?
So there's I can only take one. I've got one.
You only have one?
And it'd be Kennelly.
Really?
Because he is such
in your face, Nakashima.
I know.
No, in your face.
Like, do you know my last name?
Well, every time, yeah. But every time I eat with Nakashima, he's like, "Is this good?" I'm like, "Don't you have a tongue? Don't your taste buds work?"
He would ask that question.
Yeah, and Kennelly is like, he's fancy. Right?
Okay.
And he's
so he
like,
would appreciate it.
Yeah. He would appreciate it, and there's always good conversation with that guy, right?
Yeah, absolutely.
Cool. Yeah. So I would take him.
Well, fantastic
awesome.
Answers.
I love it.
Yeah,
that's great.
He would love that restaurant. It's right up his wheelhouse. Like he has the wood-fired pizza oven in his backyard. He's always like smoking something.
Yeah.
He's a lunatic with barbecue stuff. So he would appreciate
barbecue
it.
Stuff.
Yeah.
That's the. So far, this question has given us some of the best answers we've seen yet. So, Chudy, awesome. Thank you for joining us again. It's the last podcast of the year. It's almost Christmas, and we're closing down the college today. So it was such a joy to be here and chat with you. So to all of the people listening, I hope you have a fantastic holiday break. If you're listening at this time, if you're not, don't feel.
Well, if they're not listening, it doesn't matter. Feel
true.
bad. Feel bad if you're not listening.
Yeah.
And we'll see you in the new year.
always send an email if you have any questions. The email will be in the description. And yeah, that's all, folks.
This has been the Talking with SOT podcast with Harnick Gill and Ian Campbell. Thanks for listening.